Hey everyone, we're back here at the Maysteel Allenton headquarters. Our first video went so well, we said, hey, let's go for number 2. So I'm here with Bob Kinsey, who is a Maysteel Engineering alumni, and Andy Smith, who is our Maysteel Design Engineering Manager. And we're here for number 2 on metal joining. So metal joining can literally make or break your sheet metal enclosure. And we get a lot of questions on what type of metal joining should I use? Should I use welding or fastening? What is best for my enclosure? So I'm going to leave it once again to the experts to talk about types of metal joining, the pros and cons of these types of metal joining, real world examples on these metal joining techniques. Where do you see these used every single day? So who is going to kick it off? I think it's going to be Bob. I have a feeling.
Yeah, you're right. You have the right feeling, Lindsay.
I did. Bob's going to kick it off for us today.
We're going to kick it off. And you bring up a good point. You know, people always ask, well, you know, what is the real best way to join?
Mm-hmm.
And we always say it depends upon your application,
Mm-hmm.
what you need. We always encourage people to check with our engineering staff when Andy and his group and make sure that we understand the application best.
Mm-hmm.
Some of the basic types of welding, we'll just start with welding. Mm-hmm. Welding is an easy process. You've seen it. A lot of the green enclosures you see, platform, it's all done with arc welding. So the 4 types of welding we would use would be conventional MIG welding. Stick welding would be real heavy materials. But conventional MIG welding, in which you use a MIG welding torch with a wire feed that comes through the cone and produces a joint. That's the one type of welding. You see that a lot of places. That's more of a heavier gauge welding. Big enclosures and tanks would be MIG welded. Second type of welding you would see would be TIG welding, tungsten inert gas welding. And that uses a different type of torch. Tungsten electrode, form a cone, and that can be done to either fuse the material, just 2 pieces of material themselves, the fusing, or you can do the same thing with using the cone, but then what you would do is you would take and use a filler material with the TIG torch, tungsten inert gas. Very good for cosmetic welding and joining of parts with a locking feature to work it as well. A little higher heat, but a really nice cosmetic weld in a slower time. The third process would be conventional spot welding, and that is done with just taking a pair of copper electrodes and putting a part together. That creates a bigger joint, but it's also a bigger sized fuse joint, because if you look at this one here, it's a bigger type of joint. And with a spot weld, you're simply just, a lot of times you're filing the point, keep it clean. Every time you file it, that creates the fuse zone. It changes or loosens it. So that's a process, you have to be aware of it. And especially if you're doing with coated materials, you have to clean the materials first. Last process in welding is projection welding. And what that is my wife's pots and pans here. The handle on the pot and pan is held up with a projection weld. If you look at that, there's 8 little bumps in there. That's a weld that fuses the part together. You create a little emboss. All that's done is you take a pair of male and female die cavity, just like this, and you create a little emboss in a part. Very simple to do. That's a projection. What happens is then the heat is focused on that projection with a pair of flat electrodes. The flat electrodes are ground and finished in a grinder, so the heat is very focused on one spot. And creates a very solid weld. Also very cosmetically pleasing, because if you look inside of my wife's pan here, there's no marks on the inside whatsoever.
I don't see any, but make sure you give that back to her after this, Bob.
Oh yes, absolutely, Linda.
Can I show us a little bit more?
4 processes.
Yeah,
and Andy's going to elaborate a little more for us.
Yeah, I've got a real good example showing the difference between the spot weld and projection weld as well. Something that we actually changed in one of our designs. The first one I'll show you is actually doing the spot welding, as Bob was talking about, where you've got the material there, you've got a file down, but you do get some sort of a reveal. As you kind of see across the top there. And then when we went back and revamped the design, we actually went with the projection weld, as Bob was talking about. It definitely gives a better cosmetic look overall. Your metal finishing really goes away, almost completely away at that point.
Oh, wow. Could you hold the 2 up side by side so we could take a look at the before and after?
Yeah, definitely.
Awesome. I think it's nice for everyone to see. So the before and the after. Wow, that does make a big difference.
And then another real good example, I know Bob kind of showed, but just another example here too, showing the dimple in the material that's produced as you do projection weld. I've got an example here as well.
Mhm. Got it.
Now, if you look at the Andy showing you there,
Mhm.
one of the advantages of that is you can make all those welds at one time on one plane. That's a really nice
Really?
advantage of projection welding. Oh, yeah, absolutely. Like Andy's got.
Instead of one by one by one,
One by one, you can do it more at one time.
And
right?
because it's more focused, you can get into a narrow flange too, into more of a narrow area. I've got an example here where we hemmed over a flange and it's a pretty short distance that we had to try and tack in to make that a permanent joint. Definitely an ideal situation in this case.
Got it. Well, great. So, I mean, we've seen the different types, but I mean, people want to know, when should I use it again? They're going to go back to that. What are the pros of using welding on my sheet metal enclosure? What are the cons? Those types of things. Can you dive a little bit deeper into that?
Yeah, one of the key things that actually we take into consideration is design intent on your enclosure, on your assembly. What are the requirements as far as letting moisture into the cabinet? You start getting into your NEMA ratings of your cabinet is a big concept and a big term that we hear every day here at Maysteel. If you look at something that's a NEMA 3 rated cabinet, you want to keep moisture out. You really don't want the components getting wet, but if a little moisture gets in, it's not as much of a concern. There's a drain hole usually in the bottom. We get away with things like stitch welding, where you're skipping across your joint there and not doing a continuous seam all the way across.
Mhm.
We do a lot of the spot and projection welding there, as you've got flanges to go and attach the different pieces together. Where it gets a little bit more difficult and a little bit more consideration needs to be taken is when you look at things like NEMA 4 rated cabinets. That's completely welded shut. We don't want any water getting into there. You've got those big green electric junction boxes you see in the subdivisions around by your house. You really don't want water mixing with that electricity inside. We have to make sure that that's continuously welded all the way across in a full seam weld across. You've got to be careful when you look at that though, because a lot of heat is going into that steel, especially when you're talking thinner gauge material. You're going to start to see other things to consider there, as far as your material is going to start to warp and get kind of that wave in it as well.
Awesome. So playing off something we talked about in our last video on our metal enclosure design tips vlog is metal fastening. So we said don't go too heavy on the hardware, but it sounds like there's a place and a time for hardware when we look at metal joining. Can you go into that a bit?
Yeah, sure. Bob,
Awesome.
I'll let Bob leave that one off.
Bobby, he always makes you start.
Oh, that's okay. It depends again, of course, with the application and hardware. Right. Hardware can be defined as a lot of different things. It can be simple hardware like a screw, nut and bolt hardware, which has an advantage to a certain point. It's self-aligning. You can have two pieces together and they'll align together to create a joint. Okay. You can have a PEM hardware, which is an insert hardware, which Andy's going to show you examples of these in a minute. But you can have an insert hardware like Andy's got on that part, where you put the insert in. Again, it's accurately located because of a punch hole. You squeeze it and press it together. And then all you need is another hole in the mating part. You can put the other part through it, and then you can put a bolt, a nut on it, and you clench it together. So that creates a joint. Very simple joint. Then there's riveting. Pop riveting is a very simple example for us. And Andy, I know, has some examples there, but there, you just have a conventional pop rivet here. I'll show you here. There again, they're self-aligning because there's a pair of holes, one in each part. You put them together, there's only one axis of accessibility required.
Okay.
And in pop riveting you use a lot in aircraft manufacture as well as our manufacture as well. It's an easier process, but again, you don't want to put 300 of them in one enclosure, because then you have to pay the cost of the pop rivet plus misshooting the pop rivet. So it's a fine line there to see what you can do with that. Okay. Another process you can use would be toggle locking, clinching, and that's taking two parts, piece of each, and you take a male and female punch and die and create the joint. So you have the female punch on the button side, you have the male punch on the other side, you bring them together and you create a joint.
Oh, I
Very
see.
simple. It's
Got
a
it.
cold form process. Used a lot in wash machines and dryers. You just can't see the joints because they're hidden on the bottom.
Mhm.
Used in self-checkout machines. Office furniture is another big piece for it. And even some of our components in our cars, because this process works well with stamping tools. That's
Oh, wow.
so it works really good. There's
And
no
what
heat.
is, that's a piece that goes in a car, you said?
That's an airbag enclosure. This is a side-mounted airbag enclosure.
Got it.
It's been put together, and it's been clinched together with toggle joints.
Got it.
You just put it on the side of the car and the bag pops out. But what automotive manufacture, a lot of that stuff is done with stamping tools, and these punches work really good in stamping. Put them anywhere you want to put them.
Got it.
You don't have to worry about electricity, so you can have a part 100 inches long. You can clench 35 or 40 joints in one cycle, which is a very efficient process.
That sounds pretty efficient. That sounds pretty efficient. So it sounds like with these as well. So I know we always say go easy on hardware and fasteners, but it sounds like there's some definite times when you should use them. What's a pro of using a fastener or a rivet on a metal enclosure?
Really, as Bob talked about it, trying to take some of that heat out of that assembly. You can get away with thinner gauge material. You take out the equation of getting some of that warping in the part. It's generally on a smaller assembly a little bit easier because we can set up a fixture and they can fairly quickly go through and pop in the half dozen rivets, whatever it takes to bolt or to put that together. One thing to consider is we don't always necessarily have to look at riveting or fastening either. I've got a couple of real good examples here. We put, and I know we touched on it in our last video, was form features into the parts that help interlock the parts together too. I've got one here that we actually went and formed in more of like a tab that then hooks into a slot on the mating part that I can show you.
Well, now I can see it. There you go.
And then your mating part.
Yeah. There you go. Oh, that's pretty cool.
Another good example there as far as keeping the heat out and keeping your cosmetics down, doing more of that formed in almost like a zipper design where they kind of interlock on each other. I've got almost looks like a trash bin here, if you will, that we ended up
Pretty small one.
like that. We're really considering on the cosmetics, cutting down on the assembly time here as well. It's something that real quick puts it in with a form feature. We can fairly quickly snap the pieces together then.
So literally just snaps together.
Correct.
Literally. Awesome. Well, those are pretty cool examples. So what are some real world examples we'll see every day?
Well,
What
here's
can I
one,
see?
Lindsay.
Oh,
Here's
see,
one that
Bob's
we
ready.
use. Here's one, Lindsay. We use this. This is a cosmetic surface. This is a part of the shelf.
It's a part of what was that, Bob? We lost you for a second.
It's a shelf. It's a pull-out
gotcha.
shelf in the self-checkout machine.
Awesome.
What we do with this is that's a very high cosmetic stainless part grain.
Mm-hmm.
What we do is in order to fasten the slides on the inside, we use 3M brand VHP tape.
Okay.
High frequency bonding tape. Works really good. It's on the bottom side of these. We have strips that go on the bottom of the slides. We put them together and set it and clean it. It works out really good. It holds it together very nice for this application and goes back and forth. And then the big thing is when you see the other side, there's no blemish, there's nothing on the other side at all. There's no secondary finishing required whatsoever. When you have a beautiful surface like this that's grained, you don't want to take any chance of putting heat or anything that might distort it. So you have to sit there and regrain it again. So in some applications, we use the very high bond tape as well. It works perfect for that kind of a joint.
Awesome. Awesome. Well, man, we flew through number 2. I feel like we're getting better at this, Bob and Andy, and hopefully we're just going to continue to get better. We are going to look at number 3 coming December, January timeframe. So join us for that as well. You can see all these videos on our YouTube channel, Metal Enclosure Design Tips. So thank you both for teaching me something once again on metal joining. If you have any questions, leave them in the comments, leave them on our social, wherever you're seeing this video. And hopefully we'll see you for number 3. Thanks, guys.
Bye-bye now, Lindsay.
Bye.